Good evening, everyone. Welcome to O-level physics lesson. This is our third lesson on current of electricity. Okay, my name is Mr. Chu. Today is Tuesday, 19th of April. Okay, let's begin. Okay, all of you have gotten the formulas correct. So I think all of you are very familiar with the formulas of this topic. Okay, let's continue with questions. Okay, let's quickly do question number 31. Okay, do question number 31. All of you may begin. Type the answer onto the chat. Okay, Bei Kwan, your answer is incorrect. Try again. Yu Ting, incorrect. Okay, Oscar, incorrect as well. Okay, the reason why most of you got it wrong is because you see the word diameter. Okay, and let me explain why all of you got it wrong so far. Okay, do you all remember the formula? How resistance is related to the component, the factors? So resistance is equal to the constant, every material has a constant, multiplied by the length over the area. Okay, the key thing why most of you got it wrong is because this component below is the area. Okay, we're talking about the area here. Okay, the question here mentioned is the diameter that is 3 times larger. Okay, 3 times larger. So what happens if your area is, so now the area is how many times bigger? Okay, your diameter is 3 times larger. So how about your area? Your area is how many times bigger now? Okay, that's the clue. Okay, and this is why most of you got it wrong. Okay, Oscar, well done. Okay, so only Oscar give me the correct answer. How about the rest of you? Where are all of you? Bei Kwan, incorrect. Your resistance is now much bigger. Why? Why is your resistance much bigger? Ryan, incorrect. Incorrect. Bei Kwan, well done now. Well done. How Rui, incorrect. How Rui, the keyword here is diameter. Okay. Ryan, well done. How about the rest of you? Anybody need help? Okay, so if the length is increased by 2, your resistance will be multiplied by 2. That makes sense? Okay, so this is times 2. Now, if your diameter times 3, your area will times how many? Think about it. If your diameter is times 3, your area will be times how much? Okay. How do you convert length to area? If your length is 3 times longer, what happened to your area? If you don't remember the max, you can do your calculator. Go and count. If this is 1 by 1, what happened to the area if it's 3 by 3? Or another way you can do is, your circle, if it's 1, what happened if your radius becomes 3? Does your area increase by 3 times or something else? Okay, go and calculate. Okay, so if the area here is 1, if the length is increased by 3 times, your area becomes 9. Make sense? Likewise, if this area is pi 1, okay, it's pi. What will be the area of this? This will become 9 pi. Okay, so it becomes 9 times longer. Clear so far? Okay, so your area becomes so area becomes 9 times more. Okay, so your resistance will become 9 times smaller. Okay, so originally your resistance is 9. Your new resistance will be 2 over 9 of the original resistance. And then what's your answer? Okay, Xiaoxing, correct. So do all of you know the why most of you got this wrong at first? Does it make sense? Okay, how about the rest of you? So what's the answer for this? Okay. Well done, Yuting. So if your resistance is 9 ohm at first, you multiply by 2 over 9, your answer will be A. Is that clear? Because 9 times 2 over 3 square, your answer will be 2 ohm. Okay, answer will be A. Okay, if all of you understand this explanation, can you all give me a thumbs up? If you understand how to do now, can you give me a thumbs up? Thank you. How are you? Okay? All right, let's do the next question. Okay, the next question will be 34. Okay, do question number 34. Okay, you may begin. Okay, Oscar, you got it correct. Well done. Yuting, your answer is for the previous question or the current question? Xiaoxing, your answer is correct. Very good. Yuting, well done. Bei Kwan incorrect. Try again. Ryan, well done. Okay, Oscar, can you do your working on this space here for everyone to see? Okay, Bei Kwan, you try again. You show me your answer. Okay, Oscar, if you are there, okay, just write down your working on top here. Bei Kwan still incorrect. Bei Kwan, can you tell me what formula you need or you'll be using? Yes. So your time is in what unit? Your time should be in what unit? What's the SI unit for time? Okay, try again. Oscar, if you are there, okay, I see your answer already. Okay, Bei Kwan, try again. How about the rest of you? What is your answer? Okay, this is correct. Well done. Okay, Bei Kwan, well done. How are you there? Okay, so as you can all see from the Oscar's working, the answer for 34 is A. Clear? Okay, let's do the next question. Okay, do question number 31. Okay, this one is a standard definition question. So start doing question 31. You all may begin. Okay, Ryan correct, Xiaoxing correct, Oscar correct. How about the rest of you? Yiting correct. Ryan find this very, very comical, huh? Okay, Bei Kwan, well done. Okay, so let me just write down the formula that all of you should know by now. Okay, you should know it as Q is it. That's how I remember. If not, from here, you can actually make I the subject. Your formula should be I equal to Q over T. Okay? So I is this one means rate of, this is the charge. Okay, so the answer will be either A or B. And then the unit for current is the ampere. Okay, so the answer will be A. Okay, so for this question, I expect that all of you should get it correct. Okay, let's do the next question. Question number 32. Okay, you may begin. Oscar, incorrect. Yu Ting, incorrect. Bei Kwan, well done. Hey Ryan, why today you always choose the same answer? Xiao Xing, incorrect. Try again. Okay, I think let me explain to you using the idea of a graph and how to find the thing. Okay, so let me give a simple graph that all of you are familiar. Okay, this is the speed time graph. Is that clear? If I have a straight line, I want to find the acceleration. Okay, the acceleration is the gradient. And the gradient is the change of v over change of t. Is that correct? Did you all learn this before? I use another example, distance time graph. Okay, same thing. If I have a gradient, the speed, okay, the speed is equal to the gradient. Am I right to say that? And the gradient is change of distance over change of time. So how steep the graph is, the greater the gradient. Okay, so now going back to this question, you know that resistance, the formula of resistance is V over I. Okay, so the clue that I want to bring to you is this. Okay, this is something you need to understand. You see the formula here? The gradient acceleration is change of V over change of T. The top part is always the y-axis. The bottom part is the x-axis. Okay, another word to say is this. Okay, same thing for the gradient. The top part is always the vertical axis. And the bottom part is always the horizontal axis. Okay, so I want you to remember, okay, in your SPA, if they tell you, please draw or please plot a graph of current against PD. It's always, the first word is always the y-axis. Okay, so if I were to ask you to plot a graph of this one, I would say that please plot a graph of velocity against time. Okay, in this case, please plot the graph of distance against time. So for this graph in the center, okay, you must say that please draw a graph of current against PD. So the first word you use is always the vertical axis or the y-axis. You want to remember from the max method. Okay, the second component is the horizontal axis. Okay, so in this case, the gradient, okay, the gradient is equal to change of current over change of PD. Am I right to say that? Okay, in this question, the gradient will be change of current over change of PD. But in your question, you know that the formula of resistance is V over I. But the gradient is I over V. You understand what I'm saying? So from P to Q, I over V is 0. So resistance will be the opposite. Opposite of 0 will be Okay, so from here, can you all please continue to do? Okay, I try to explain this as best as I can. If you are still confused of what, if you still don't understand what I'm trying to say, type help in the chat. Okay, type help in the chat if you still don't understand what I'm saying. If this is something very new, okay, can you please type thank you? Okay, if you didn't know this already, you just type. I don't need to type anything. So if nobody say anything, means you already know what I said so far. Okay, if it's something new, say thank you. If it's something you're still not clear, type help. Okay, so I know where you are. And up to now, nobody type anything. Why? Okay, thank you, Bei Kwan. Okay, so now you know what I'm saying. Can you do the question? So for question 32, what's your answer? A, B, C, or D? Chelsea incorrect. Yuting, well done. Yuting, well done. So Chelsea still don't understand. Still don't understand what I'm saying. Okay, so far only Yuting got it correct. How about the rest of you? Oscar incorrect. Howry, well done. Oscar, you got it. You got it now. Well done. Okay, so for those who are still not clear, let me explain one more time. Okay, let me explain one more time. Okay, when we talk about gradient, okay, the symbol is M. It's always talking about the rise, change of rise over change of run. You learn this in lower side mathematics, am I right? Okay, this is also the same as change of y over change of x. Up to here, is that clear? A gradient is always how much your y changes, the rise, over the run, which is change of y over change of x. So for this question, if I were to draw a gradient here, let's say there's a gradient here, okay? The gradient would be change of current over change of PD. So the gradient for this question is change of current over change of PD. Clear so far? Then next thing, all of you need to do is to find the resistance, which is V over I. Okay, to find the resistance, you need to find the V over the I. Okay, let's do the first part. The first part, we're talking about P to Q. Okay, let me highlight the point. P to Q is from here to here. Can you see? So from here to here, the gradient is 0. Am I right to say that? So if I were to sub in, I, change of I over change of V is 0. Okay, so it is 0, it's flat. But we know that resistance is V over I, not I over V. So if you were to flip, you let the PD be the y-axis and let the current be the x-axis, how will it look like? If I try to flip, this is your V and this is your I, your graph will look something like this. Correct? This is your P, this is your Q. Am I right to say that? So same thing, you look at this part of the graph from P to Q, the gradient is very steep. Okay, so it's very steep. So V over I very steep means the gradient is very large. The resistance is very large. Are you clear about this? Now, can you see from this graph, V over I, what happened to the gradient here? Okay, let me just draw a few gradient, and then you should be able to understand what I mean. Okay, so at first the gradient is like this, then the gradient is like this. So can you see the gradient become less and less steep? So the resistance become less and less. Is that clear? Okay, so the answer for this will be decrease and decrease. So the answer would be A. Okay, so if you are confused about looking at it in opposite manner, you can resketch your graph to V over I. Because V over I or V against I is the resistance. So the gradient of the graph will give you the resistance, the instantaneous resistance. Is that clear? Okay, so those who Ryan, I'm just trying to joke with you. Okay, so if you understand this question now, okay, give me a thumbs up. Okay, if you understand this question, which is very interesting, if you understand the concept behind this question, it'll be very powerful because you learn how to read a graph. You know that vertical against the horizontal is the gradient. And then you know the formula V over I, the vertical against the horizontal is your gradient. It will give you the value here. Is that clear? Okay, so let's do the next question. So this is a very good question. I like this question. If you understand this question, you will understand a lot of things. Okay, let's do the next one. Do question number 33. You may begin. Okay, anybody of you need help? Okay, Oscar, good try, but try again. Okay, still a good try, but try again. Yeah, just guessing, right, Oscar? How many of you need help? Type help. Okay, first of all, Xiaoxing, try again. We're talking about this thing is a torch lamp. So torch lamp is not a ohmic. Okay, it's not a ohmic conductor. Meaning, ohmic conductor looks like this. V versus I or I versus V is a straight line. Okay, this is an ohmic conductor. So what is the, for a torch lamp, how would it looks like? Okay, how Ray, Bei Kuan, incorrect. Try again. Okay, the torch lamp, you must remember as the current goes up, okay, as the current goes up, the resistance goes up. Okay, so for a lamp like this, how would the graph look like? Okay, I use a VI graph. It should look like this. Okay, because the gradient should go up. Can all of you see the gradient like this? Okay. So at the point where it is 3 volt, it will give you 0.06 ampere. Clear? So now you know that this is how it looks like. So all of them, 3 volt will give you 60 milliampere. So the 3 is all correct. All of them, if a 0 is all correct. So which one shows this type of graph? Okay, so you got your 2 and 3, 2 and 1. So from this graph, can you see what should your answer be? Okay, so first of all, you know that all 60 will be wrong. You also know that this is not an ohmic conductor. If an ohmic conductor will be a straight line. So for number C, C is ohmic. Okay, your gradient is all the same. Can you see that? So C will be incorrect as well. Okay, how does A looks like? A looks like this. Your voltage and your current. Okay, it looks like this, straight line. Okay, so this is not correct. Okay, the ohmic will be like this. A straight line like this, V versus I. So that is also incorrect. So the question now is the answer B or D? Incorrect. Can you see at 1 volt, it is a bigger value. 2 volt, it increased a little bit. 3 volt, it increased even lesser. So what should the answer be? So 北关 will from correct become wrong. Ryan, well done. Or this drawing not very clear, so let me redraw. Okay, let me redraw. Not very clear. Okay, VI. Okay, you can see as the current goes up, the resistance goes up. Okay, why the resistance goes up? Because you can see that the gradient goes up. Can you see? The gradient becomes steeper and steeper. Okay, so let me split into 3 parts. My vote, we got 3, 2, and 1. Okay, we got 3, 2, and 1. So my 3 will reach this point and here. My 2 will reach this point and here. And my 1 will reach this point and here. So can you see over here? When it's 0, it will be 0. Okay, so I use the unit milliampere. When it is 60, is here. So can you see down here? When it's 1 volt, the value should be very high. 2 volt, even higher. So the gap here becomes smaller and smaller. That's how your gradient can increase. So the question now is based on my drawing here. Okay, the gradient, which is the resistance, is going up, is increasing. So my gradient is increasing. My resistance is increasing because for a lamp, as your current goes up, your resistance increases. Is that clear? So from based on this idea, will your answer be B or D? Or do you want me to sketch the graph? How does B and D look like? I can do that. V and I. So that's 1, 2, 3. Correct? So I just give a rough 10, 20, 30, 40, 50, 60. Okay. I use red color, red to do B. And I plot red color to your. Okay, I use red. Okay. So 0, 0 is here. 125 is here. 245 will be here. 360 will be here. Can? Now, if I were to plot the blue, I use the D to use blue. 0, 0, same place. 110 is here. 220 is here. And 360 is here. So can you see? The blue will look like this. The red will look, hold on. Okay, the red will look like this. Okay, so from here, can you tell me, will the red graph looks like this or the blue graph looks like this? Which one has an increasing gradient? Because V over I, resistance is equal to change of V over change of I. So if I want an increasing gradient resistance, my gradient should be increasing. So can everybody tell me your answer? Nobody is with me. You just stop down there. I don't. Okay, Yiting, well done. You got it now. Well done, Yiting. Very good. How about the rest of you? Ryan, well done. How Ray, well done. You got it? Is it simple? How about the rest? Oscar, Xiao Xing, what's your answer? Oscar and Xiao Xing incorrect. Oscar and Xiao Xing, can you see here? If I want my gradient to increase, my shape of the graph should look like this. Okay, this one on the right. Okay, it should look like this. So the B answer I plot in red. The D answer I plot in blue. So which one looks like this? Okay, Oscar, well done. Chelsea, are you still confused? Okay, Kwan, where are you? Okay, Bei Kwan, well done. You understand now? How about for Chelsea? Do you understand? Chelsea, are you still there? Are you okay with me? Chelsea, are you there? Hello, hello, Chelsea, Chelsea, are you there? Okay, what's your answer, Chelsea? Chelsea, what's your answer? Okay, you all got it? Okay, I hope that you all learn to appreciate graph better now. Okay, let's do question number 29. Okay, start doing the question 29. You all may begin. How many of you are confused and need help? Type help in the chat. Maybe you can't make up your mind, what's your final answer? Okay, Ryan incorrect. Pei Kwan incorrect. Oscar incorrect. Oscar, well done. Howry incorrect. Try again. Pei Kwan, well done. Xiao Xing, well done. Okay, so this current here is the conventional current. Okay, so electron flow will be the opposite direction. Is that clear? Okay, electron flow will be the opposite direction. Okay, so left to right is wrong, right to left is correct. Okay, so for this question, you need to know Q is it. Okay, or you can just write down I is equal to the charge per, okay, the rate of flow of charge. Okay, current means the rate of flow of charge. So 0.32 ampere is the same as 0.32 coulomb divided by 1 second. Is that clear? So it means that every second there is 0.32 coulomb of charge. So the question here is they are all per second. Okay, so the charge itself, Q, should be 0.32 coulomb. Okay, so you know that the charge of one electron is this value. So how many of this value are there in 0.32 coulomb? And that is your answer. So is it 2 times 10 to the power 18 or is it 5 times 10 to the power 18? Okay, so basically number of electron is equal to 0.32 divided by 1.6 times 10 to the power minus 19. Okay, can all of you go and calculate this and tell me what is the answer? Okay, the answer will be 2 times 10 to the power 18. Clear so far? The number of electrons will be 2 times 10 to the power 18. The other thing that I want you to also try to, okay, for this question, you don't need to calculate, you also can make sense. Does it make sense that in 1 second there is 5 times 10 to the power negative 19 electrons, okay, moving in every second? Cannot be, right? This is so small number. Okay, so it's a very small number like this. Okay, definitely you know that it doesn't make sense. It should be a lot of electron flowing. Okay, so from here, can you see? 10 to the power 18 is a big number. 10 to the power 19 is a very small number. It can't be a fractional, a very small fraction of electron moving from left to right, right to left every second. Okay, are you clear about this? So without even calculating, okay, you have guessed the answer will be A or B. Okay, it can't be a very small number. It must be a lot of electrons. Am I right to say that? Okay, so the answer for this will be B. Clear so far? All right. If all of you understand the answer for this, give me a thumbs up. Yeah, move on. Thank you, Yiting, Oscar. The rest of you, do you understand? Thank you, Harry. Ryan, Bei Kwan, and Xiao Xing, are you there? Thank you, Ryan. Bei Kwan, Xiao Xing, are you okay? Okay, let's do the next question. Question number 30, you may begin. Okay, Xiao Xing, well done. Oscar, incorrect. Try again. Bei Kwan, well done. Harry, well done. Yiting, well done. Okay, these two cancel out. These two cancel out. These two cancel out. These two, they cancel each other out. Okay, this one, they cancel each other out. Okay, this one, all cancel out each other. Am I right? Okay, so what's the answer for this? From here, can you see what's the answer? Okay, Oscar, well done. Ryan, well done. Okay, so this is 1.5 plus 1.5. This is 1.5 plus 1.5. This is 1.5 plus 1.5 plus 1.5 plus 1.5 equal to 6 volt. Okay, the answer is C. Clear? Okay, let's do the last MCQ question before we go for a short break. Let's do question number 31. You may begin. Okay, this question really tests your understanding of your formula. Xiao Xing, well done. You're very fast. Yiting, well done. Very good. How about the other four boys? Howrey, well done. Oscar, well done. Ryan, well done. I'm left with Bei Kwan. Okay, Qiao can you give me the working for this? Yiting, can you give me the working for this? Put it on the screen and show everybody while I wait for Bei Kwan. Okay, Bei Kwan, well done. Okay, so Qiao and Yiting, can you give your working for current and PD onto the screen? Okay, everybody understand now? If you understand, give me a thumbs up. Okay, the answer for this would be B. Okay, if you understand, give me a thumbs up. Then go for a 2-minute break. Be back by 8:35. So only Ryan and Bei Kwan can go for a break. The rest are no thumbs up. You stay here with me. Oh, Oscar, you may go for a break. Okay, thank you, everybody. I'll be back by 2 minutes. Okay, welcome back. For this question, you all may begin. So far, Bei Kwan, Hao Rui, and Oscar got the A correct. They got the A correct. Then for part B, this is 80 ohm. So going to calculate the total resistance. Okay, the rest of you, why are you so slow? Yiting, your A is correct. Okay, Yiting, your B is correct. Yiting, your C1 is correct. Hao Rui, your B is correct. Well done. Hao Rui, can you do the working of part B on the screen? Thank you. Share your answer with everyone. Okay, I'm going to write down the answer for A on the screen. Okay, the first answer is light dependent resistor. Okay, Hao Rui, can you do part B onto the screen? Thank you. Okay, well done, Hao Rui. Okay, you may add this in. Okay, correct. Okay, how about the rest of you? Where is your answer? Oscar, your definition for C part 1 is correct, but there's no need to tell me the units. Okay, let me share with you the answer for part C. Okay, C is the definition all of you should know by now. Okay, so current is the rate of flow of charges. Okay, you want to be more specific, you can say electric charges in a circuit. Okay, that is the meaning of current, okay, which is Q over T. Okay, so what happened to the current in the battery when the light intensity increases? Okay, so let me explain to you. When light increases, okay, what happened to the resistance? Okay, the resistance will go down. So this resistance will go down. So when the resistance go down, your total resistance will go down. Is that clear? Okay, when your overall resistance go down, your current will go up. Does that make sense? I repeat myself again. When the light increases, okay, light intensity increases, the resistance of this light dependent resistor will go down. So when this resistor go down, okay, for example, this 80 become 10. You're going to calculate. Okay, you're going to calculate. This value will become lesser. Okay, let's all calculate now. Okay, so when I change to 10, right, this whole thing, okay, this one itself is still 20 ohm. Okay, originally it is 40 ohm. When I change to 10, it actually dropped by a lot. Okay, it's about 9 ohm, about 9 ohm. Is that clear? Okay, so your this 60 ohm will drop to 29 ohm. Okay, become 29 ohm. So when your resistance will drop by almost half, for example, less resistance, more current will flow through. Clear so far? Okay, why so? Okay, why is that so? V equal to Ri. Your V is fixed. Okay, when your R drop, your I will increase to maintain the fixed V. Is that clear? Okay, so for part 2, when the light intensity increases, the resistance will decrease, the total resistance will decrease, and the current will increase. Okay, if you are clear about this question, give me a thumbs up. If you are still confused, give me a write down help in the chat. Oh, okay, Okay, let's do question number 5A. Oh, that's the one. Okay, I want all of you to type up. Okay, 2 mark question. Give me your answer in 2 minutes. If the connecting wire is thicker than the wire used in the filament grows brightly, but the connecting wires do not grow. Why? Okay, 1 minute up, 1 more minute. Quickly type. You can write point form as well, it's okay. I want to know whether you understand your concept. Nobody giving me the answer. Okay, Ryan first to give me the answer. Let me read. Okay, Ryan, incorrect. Try again. Okay, Kwan, I'll give you 1 mark for this. The question says the filament grows brightly. Why? Okay, and then the connecting wires do not glow. Why as well? Okay, so you need to answer these 2 parts. These 2 parts, I'll give you 1 mark each. Okay, Yuting. Okay, Yuting, I'll give you 1 mark for your answer. Okay, you actually explain why the filament glows brightly, but you did not explain why the connecting wire do not grow. Okay, I think I can give you 2 marks for your answer. How about the rest of you? I'm waiting. The rest of you, where's your answer? Hello, the rest of you, where's your answer? 2 marks question, I say 2 minutes. Okay, Oscar, incorrect. Okay, let me explain this question to you. First of all, they are of the, okay, can you see over here? First of all, you can say that the connecting wire is thicker. Okay, so thicker means resistance comes down, okay, and your current goes up. Okay, that's the reason why the connecting wire do not grow, because the resistance is low. Okay, why does the why the filament bulb glow brightly? Because there's also a high in current. The next thing, the filament because it's not so thick, it is very thin, so the resistance is high. So it's hard for the current to flow through. Okay, hard for the current to flow through, and therefore it will light up. Clear? Any question for this? Are you clear about this? Okay, so first of all, connecting wire is thicker, so the resistance is lower, so current can flow through. So therefore, the wire do not glow because the resistance is low and the current is high, so the current can flow through. Next, the resistance of the filament is very high, it's very thin, so the resistance is high, and therefore the light bulb will actually light up. So let me just type it out for you so that you can have a reference if you want to look back at the video. So far, very little of you look back, right? So I shouldn't type one. Okay, the thicker connecting wires have a lower resistance. Let me change the color. Then the filament, which means, okay, less energy is converted to light energy. Okay, light and heat energy. Does that make sense? So it will not light up. Clear? So hence it will not glow. Okay, then the material used for the filament has a higher resistivity than the connecting wire, which also increases the resistance of the filament, causing more energy to convert to light, making it glow. Is that clear? All right. If you understand this, give me a yes reaction. Then we go through one last question and then we are done for today. Thank you, Ryan and Yuting and Oscar. The rest of you, where are you? Thank you, Hao Rui. Bei Kuan and Xiaoxing, are you okay? Okay, let's do the last question and then we are done for today. I want to do two questions, but it take so long to do this question. Okay, I don't know whether you can see. I just need you to do B part 1 and part 2. Okay, once you get the answer, okay, part 2 is 2 marks. I call your name and you may leave. Okay, so I want you to write down not just the answer, but your formula working and the answer. Okay, do that together. Okay, do that together. And then once I call your name, you may leave the class. Okay, it's a very simple question. Once you are able to give me the answer, I call your name, you may go. Ryan, part 1 is correct. Oscar, part 1 is correct. Well done. Ryan, I want to see your formula. You never follow my instruction. Okay, Oscar, you may go. Ryan, you may go. Hey, Ryan, you're still there or not? Your okay, Ryan has left. Oscar, you got any question for me? If not, you also may go. Okay, I'm still waiting for Hao Rui, Bei Kuan, Qiao Xing, and Yu Ting. What's your answer for this? Bei Kuan, your answer make no sense and no working, no unit. So your 1950 represent what? Yu Ting, the first one is the charge. Charge is not W over V. Okay, that's not correct. Can you try again? So your A is wrong, your part one is wrong, your part two also be wrong. Okay, Hao Rui. Why you got no formula one? Okay, but Hao Rui, you got it correct. Well done, you may go. Qiao Xing, are you there? Okay, so let me give you a clue. Charge is Q. The formula used for part one is Q is it. You remember this? Formula for part two, V is work done over charge. Just use these two formula and you should get the answer. Qiao Xing, is 0.2 ampere is correct, but your answer is wrong. Okay, 0.2 ampere is correct. It's not 2 ampere, it's 0.2. So you're working, you put 0.2, by your calculator, you put 2. So count again, Qiao Xing. Bei Kuan, are you there? Bei Kuan, incorrect. What is the SI unit for time? Okay, you must be very clear. All these formula, what is the SI unit for time? Everything must be in SI unit. All right, Yuting, well done. You may go. And Xiaoxing, you may go. Okay, wait, Yuting, you don't go first. Your unit for PD is incorrect. Okay, can you adjust your answer, Yuting? Your PD unit is incorrect. Okay, Pei Kwan, I'm only left with you. All right, you're now correct. Very good. Pei Kwan, what is the SI unit for time? It's second. So you must convert your 4 minutes to second first. Okay, you must convert this to seconds. Okay, try again. Yiting, you may go. If not, unless you got any question for me. Okay, Yiting has a very good question. Pei Kwan, I want to see your unit. Okay, I want to see your unit. Okay, so let me just continue the working first. Yiting, you may just hold on for a while. This is 0.20 ampere multiplied by 240 seconds. And therefore, your answer here will be 48 coulomb. Okay, 2 SF. So, Pei Kwan, I want to see your unit. Okay, Yiting, while waiting for Pei Kwan, let me just draw a circuit for you. Okay, Yiting, you look at this circuit, I draw a parallel circuit with 2 light bulbs, correct? So for example, your battery is 1.5 volt battery. Okay, what does the 1.5 volt battery does is at first this point here is 0 volt. So the battery raise the point where the potential here to by 1.5. So on the positive side of the battery, okay, this point here, the value is 1.5 volt. And because there is nothing between the line, there's no there is no resistor or component, everything along this blue line have the same PD, same potential. Is that clear? So if I were to tap down here, you'll show 0 volt. I'll tap down here, you show 0 volt. If I tap here, you show 1.5 volt. If I tap here, you show 1.5 volt. So what does the voltmeter do is, if I use the voltmeter, the 2 point at 1.5 and 1.5, the difference between these 2 points will show you 0 volt. On the other hand, if I tap the voltmeter on the 1.5 point here, plus another point here, the difference between these 2 points will be a 1.5 volt. That's how a voltmeter does. It actually measures the difference between 2 potential. Clear? Now, so once you know that the battery actually raised the potential by 1.5, it's just like going up the stairs. Okay, going up the stairs. Okay, so this battery bring you up to level 2, okay, or level 1.5. So the resistor bring you back down to level 1. Is that clear? So let's say, okay, sorry, let the right side here be level 0. Let the left side here be level 1.5. So the battery bring you up to level 1.5. Okay, and then as a current, you can choose to go down by the first bulb or the second bulb. So for example, if the first bulb has a resistor of 10 ohm, the second bulb has a resistor of 20 ohm. Okay, so 20 ohm is harder to go through. Okay, harder to go through. So most of the current will prefer to go down the stairs of the 10 ohm bulb. Less current will go down the stairs of the 20 ohm bulb. But on the left side here, you're still at level 1.5. So if I use this to explain, does it make it a bit clearer for you? Hey, Kwan, I'm still waiting for your part 2. Your part 2, what's your answer? Okay, Bei Kwan, well done. Any question for me? So I just write down the answer here. The work done is 390 joule. The Q is 48 coulomb. And from here, you should get 8.1 volt, okay, 2SF. Clear? Okay, Yiting, you understand what I mean? Okay, maybe 1.5 is not a good number to explain. Let me use another number. Yiting, you may want to use a mic if you want. Let me use a 5 volt battery. Okay, so why here all 0 volt? Okay, so for example, when there's no battery, there's no battery, right? The whole circuit will not run. So everybody is at level 0. Okay, let me just draw the whole thing again. I use another way to draw. Okay. For example, this is the circuit. When there's nothing in the circuit or there's no battery in the circuit, everything is level 0. So if you were to point anywhere on this circuit, everything will be level 0 or at level 0. Clear? The potential is level 0. So I put a bulb here. Okay, now I put 2 bulbs here, but there's no battery in the whole circuit. So the whole circuit is also at level 0. You're at ground floor. Nothing is happening. Okay, the whole circuit is at ground floor. Okay, so what's going to happen is this. I put a battery here. The battery is a 5 volt battery. Okay, I don't want to put battery here. Hold on, let me change. Let me change. Okay, I put a battery here. Easier to see. Okay, so this point, this line is 0 volt. Okay, my battery brings you up to level 5. Just imagine your battery is like your lift. It only can bring you up. Whereas the other thing is to bring you down. Okay, so what happened is the point before the battery, or the point here, is all level 0. Okay, this point, okay, okay, so before the battery, it is 0 volt. Yeah, at level 0. The battery bring you up to level 5. So after the battery, this point is at level 5. Clear so far? So any point along here, if there's nothing there, okay, there's nothing there. So let me show you. From the positive side of the battery to here, all the way this orange line, there are nothing there. There's no bulb, there's no resistor, there's nothing. They are all at the same level. Anything along the orange line is all at the same level. You're at level 5. Okay, I use another color, green. Anything below that, like here, okay, they are all at level 0 because nobody bring you up or bring you down. So all the green point is level 0 and all the orange point is level 5. You're at level 5. So what the battery do is to bring you up in your level, and what the bulb do is to bring you down the level. So these two bulbs, they may have different resistor. Okay, for example, this can be 100 ohm, this can be 10 ohm. Both are 100 ohm and 10 ohm. Okay, but just imagine you're at level 5. Okay, at level 5, there are 2 ways to come down. There are two slides. One slide is very simple. The other slide is very complicated, then come down. Okay, so the complicated slide is the 100 ohm slide. The 5 ohm slide, sorry, the 10 ohm slide, the 10 ohm slide is the simple one. You come down very fast. So most of the current will prefer the 10 ohm slide and come down. Less current will prefer the 100 ohm slide. Okay, so both of them have different resistor but have the same volt. So this volt, just imagine it as how high you are. So they are both at the same level, okay? But the 10 ohm bulb has an easier way to come down. The 100 ohm bulb is like an obstacle. You take a longer way to come down. Okay, did I help you understand this better now? Okay, thank you so much. If no more question, you may leave. If not, you can still stay here. Let me end the recording. Thank you.